Okay, Algebra 2, so now that we finished 4.4 and we have a little bit of a refresher about how to factor, now we're going to talk about why we actually need that skill. Factoring is the first method that we're going to talk about here for solving quadratic equations. So your textbook just uses the title Quadratic Equations for 4.5, but really what we're doing is we're solving those quadratic equations by factoring. We are going to learn two more methods after this for what to do because factoring doesn't always work, but for this section, this is the first thing we're going to talk about because it's the fastest and easiest of the three methods, and when it works, it's definitely the one you want to use. Okay, so let's get started here talking about something that is really important. It's essential to what we're going to be doing, and yet even if I were to ask my calculus students, hey guys, what is the zero product property, most of them are going to have no clue what I'm talking about. Here's what it says. It's a pretty basic idea. If you have a factored expression like A times B, and if the product of those two factors is equal to 0, that will happen if either A, which is your first factor, is equal to 0, or if B, which is your second factor, is equal to 0. What I'm basically saying here, guys, is if you've got two numbers being multiplied together whose product is equal to 0, that can only happen if either the first number is 0, like for example 0 times 7 equals 0, or it could happen if the second number was equal to 0, like 11 times 0, that would equal 0 as well. So if you know that two numbers, which we're just calling A and B right now, multiply together to have a product of 0, one of those two numbers has to equal 0. And I want everybody to notice here the significance of the word or. The other word we maybe could have put there would have been and. And it certainly would be true that if both the first number and the second number were both equal to 0, then the product would equal 0 as well, but it's not necessary for both of them to equal 0. This example and this example both show that just having one of those two factors equaling 0 would be enough to guarantee that our product is going to be 0 as well. So again, the way to read this is if a factored expression is equal to 0, that can happen if either the first factor is 0 or if the second factor is 0. And we really don't need the word and. Okay, so with that basic idea, let's take a look and see it in action right here. So our directions now are to solve each quadratic equation by factoring. And let me refresh your memory, guys. From Algebra 1, what does it mean to solve an equation? Find the value or values, it could be plural, of your variable that make a conditional statement such as this true. Just picking a number off the top of my head, and I hope I don't mess this up right here. Okay. Is x equals 5 a solution to this equation? I don't think so, but let's check it. We'd plug the 5 in here and here. 5 squared is 25 minus 19 times 5, I believe, is 95, and then plus 88. Does that equal 0? I don't think it does. 25 minus 95 is negative 70. Negative 70 plus 88 is 18. 18 does not equal 0, so 5 is not a solution. Now that was me just guessing, coming up with a random number, but we're looking for an x value that will give us a true statement right here. And obviously 5 wasn't it. So here we go, guys. We're going to try to do this the right way now, solving by factoring. Now, step number 1 here is always to get the right side of your equation equal to 0 if it's not already done so, and that is so we can set up the zero product property. This only works if that right side of the equation is 0, and lucky for us, that happened here already, so we don't have to worry about it. But in some future problems, like here, for example, that isn't the case. We need to make it the case before we do anything else. So I'll make a little list over here. The first thing we're going to do is set equal to 0, but that's already done. Second thing we're going to do now is to try to factor your left-hand side. And this is what we just got done with in 4.4. So we have a quadratic trinomial right here. We're going to try to factor it. The first thing we would do there is look for a GCF, and we don't have one here. There's nothing you can take out of x squared, negative 19x, and 88. The second thing we would look for then is either a perfect square trinomial or a difference of squares binomial. This is not one of those special patterns. X squared is a perfect square, but 88 is not. So it's not a perfect square trinomial. And the fact that we have 1, 2, 3 terms here means this is not a difference of squares, because a difference of squares is always a binomial. So that didn't work out anyway, and when none of those things happened, then we basically are going here to how we quote-unquote normally factor by doing reverse FOIL, and that's what's going on here. So we're going to split this quadratic trinomial into the product of two binomials, and everybody, this is important, this still equals 0. Here we go. How do we break up our x squared? X times x. Now we look at the signs. This C value right here of 88 is positive. That tells us that these two signs in purple here are the same. Then we look over here to the sign of B, and since it's negative, that means these signs, which are the same, are both going to be negative. And now we need two numbers that multiply to 88 and combine to a negative 19. So think of factor pairs that are going to give you 88. The first one that probably occurred to you, I hope, is 11 times 8. And by dumb luck, 11 and 8 add up to 19. So we're going to put an 11 here and an 8 here. And okay, we're done with factoring here, so that's good. I just realized, guys, I goofed this up. That shouldn't have been a 3. That should have been step C right there to that little checklist that I was making. So all of that kind of goes right there. Shoot. All right. And now step 3 of this whole process, after you have factored, is we're going to set each factor equal to 0, and then we're going to solve. So this is using the zero product property. A times B will equal 0 if either A, x minus 11 equals 0, or B, which in this case is x minus 8, equals 0. If either this factor or this factor is equal to 0, the product of the entire left-hand side will equal 0 as well. And solving these is really simple. You can usually do it in your head. Here we would add 11 to both sides and get x equals 11. That's solution number 1. Or, not and, but or, here we would add 8 to both sides and get x equals 8. And everybody, this is your solution here. Now, I need to clarify, the word or, when you think about it in the context of the English language, it kind of implies that you could either give me this answer or this answer, and either one of them by themselves would be okay. That's not true. You need to give me the entire answer right here, both solutions. And so a lot of people are saying, well, wait a minute then. Doesn't that mean that we should use the word and? No. X can't be 11 and 8 at the same time. But if x is either 11 or 8, we're going to get a true statement up above. Okay, and since this is our first one, let's check this real quick. If we let x equal 11, let's see what happens in the original expression right here. 11 squared is 121 minus, 19 times 11 would be 190 plus another 19 would be a 209 if I'm not mistaken, and a plus 88. All right, so give me just a second here, guys. I'm going to go to, I think I've got a Desmos calculator pulled up here. Okay, and what do we just have? 121, that didn't work, 121, and then from there, I forgot already, it was minus 209 and plus 88. So minus 209 and then plus 88, there we go. When we hit enter, nope, that's not what I wanted. I hit the blue button. There you go. It equals 0. And that's exactly what we wanted this to be. So, yeah, 11 worked out. And we think that 8 is a solution as well. This one should be a little bit easier. Here we go. 8 squared is 64 minus, 19 times 8. That'd be 160 minus 8 would be 152. And then a plus 88. So let's try that. 64 minus 152, 64 minus 152, and then a plus 88 at the end of all that. That didn't come out right. That was supposed to be a 64 minus 152. There you go. That is equal to 0 as well. These tiny buttons on the iPad are hard to hit. Okay, so both of these worked out. These are our two solutions to this quadratic equation. And right there, guys, we see a major difference between solving a quadratic equation and solving a linear equation, which is most of what you guys did back in Algebra 1. In Algebra 1, a linear equation might look something like 3x minus 7 is equal to 23. And to solve this, you'd add 7 and get 3x is equal to 30, and then divide by 3, and you'd get x equals 10. And you would check it by putting it back in here. 3 times 10 is 30. 30 minus 7 is 23. Check, it works. Sorry. The important thing about that is that most linear equations that you guys saw in Algebra 1 had one solution. But now we just solved a quadratic equation, and we can see right here that this particular one has two solutions. Okay? And that is kind of opening the door just a crack into a major concept that we're going to talk about here later on in the first semester. It's called the fundamental theorem of algebra, but we're going to save that for chapter 5. I know the suspense is killing you. Anyway, you'll survive. All right, let me get rid of that. Let's do another one here, guys, and we'll go a little faster through this one. Now, again, step number 1 was to set it equal to 0, but that's already done for us. Step number 2 is to see if we can't factor this thing according to some of the methods that we talked about. So the first thing we discussed, let's look for a GCF, but there is no number that goes into 9 and 30 and 25. So forget about a GCF. It didn't work out. Okay, then the second thing we should do is look to see if we have a special pattern right here. And okay, it's a trinomial, so it's not going to be a difference of squares, but it might be a perfect square trinomial. Let's see if we're dealing with something here. Is the first term a perfect square? Hey, yes it is. And let me just jot this down. The square root of 9m squared is 3m. Second thing to check, is the last term a perfect square? Well, yes it is. The square root of 25 is 5. And now, here's the telltale sign. The middle term needs to be the product of this square root times this square root times 2. So 3m times 5 would be 15m times 2 would be 30m. Hot dog, everybody. This right here is a perfect square trinomial. And that means that it factors nicely into a single binomial squared. But I'm still going to put the equals 0 at the end. Okay, what's the first term of this binomial? The square root of the first term of the trinomial, which we just said was 3m. The second term of the binomial is the square root of the last term of the trinomial, which is this 5 right here. And the sign that goes in between is the same as this sign right here. So this is 3m minus 5. Quantity squared is set equal to 0. Now, this is still a practical application of the zero product property. And in that case, it wouldn't be a terrible idea to write this out as 3m minus 5 times 3m minus 5 and set it equal to 0 and go to town. But I want to talk to you guys real quick about how to solve this, because this is a nice case. Because there's just one m in this expression here on the left side, we can solve this using inverse operations, kind of like you did in Algebra 1. Let me show you how. The last thing happening on the right-hand side is the square. It's the only thing that happens outside of the parentheses. We're going to undo that square by doing the square root of the left and the square root of the right. The square and the square root cancel each other out, just leaving us with 3m minus 5 equals, and the square root of 0 is 0. Well, that wasn't that bad. Now, this looks like an Algebra 1 linear equation. Let's bring that 5 to the other side, and we're going to get 3m equals. It was negative 5 on the left, so it becomes positive 5 on the right. And then we'll divide both sides by 3, and no need to panic here, guys. I know 5 doesn't divide evenly by 3. All you have to do is write that as 5 over 3, and we are done. Now, a big difference here between the problem we just did and the previous problem. Example A was a quadratic equation that had two solutions, but example B is a quadratic equation that only had one solution. So all that proves to us so far there, guys, is that a quadratic equation might have two solutions. It might have one solution. There's more to that, but we'll leave it right there. Okay, let's take a look at example C. Now this one has a wrinkle to it that the other two did not. This has non-zero terms on both sides of the equation. So step number one was to get your equation set equal to 0 before we start factoring. You can't use the zero product property if one side isn't equal to 0. So we need to make a decision. Do we want to move all of our terms from the right over here to the left, or all the terms from the left over here to the right? Both of them will work. Well, the way you should make your decision, nobody likes dealing with a negative leading coefficient. So look at your highest degree terms, n squared on the left and n squared on the right. What we do, guys, is we move the little guy to the big guy. We're not going to move 7n squared over here to 2n squared because that would give us a negative 5n squared. No thanks. We're going to move this 2n squared over here. And that means I'm going to move all the terms from the left over here to the right. So here we go. I am going to subtract 2n squared from the left and from the right. I'm going to subtract 4n from the left and from the right, and I'm going to add 1 to the left and add 1 to the right. And as long as we're doing the same thing to both sides, we're going to be fine. Those terms cancel, those terms cancel, these terms cancel. So what remains now on the left-hand side? A big fat 0 equals, and here we go, 7n squared minus 2n squared is a positive 5n squared. That's what I wanted. Then I've got a minus 11n and then a plus 2. So, okay, we've got the 0 on the left side now instead of the right. That's perfectly fine. If you wanted, you could, okay, just do that. And now it's over on the right where most of you would like it, but I'd encourage you to just get used to it being on the left-hand side. That can happen there too. So now we try to factor the right-hand side. Checklist. First thing, is there a GCF? No, nothing goes into 5 and 11 and 2. Second of all, are we dealing with a perfect square trinomial? Definitely not, because 5 is not a perfect square and neither is 2. And it's not a difference of squares because this is a trinomial and a difference of squares is a binomial. So none of the special things worked out. Then we just roll up our sleeves and here we go, reverse FOIL. What times what is going to give us 5n squared? Okay, we haven't done much together here with a number other than 1 there. Well, the n squared still splits up into n times n, and 5 being a prime number, the only two things that multiply to 5 would be 5 and 1. But of course, there's no point in putting a 1 there in front of an n, so I'll just leave that as n. 5n times n gives us 5n squared. Now it's time to read the signs. That positive tells me that these two signs here are the same, and then I look right here, that tells me they're both negative. So minus, minus. And now we need two numbers here that multiply to 2. Normally I would say those two numbers have to multiply to 2 and add or subtract to 11. But I'm not going to say that now because the presence of that 5 there just messes everything up. So let's just focus on the fact that these two numbers have to multiply to 2. And luckily, 2 is a prime number. The only numbers that multiply to 2 are 1 and 2. Now, I don't know if it's 1 and 2 or 2 and 1. So this is what bothers people sometimes. You have to guess, but then you've got to check to make sure you're right. So I'm going to put a 2 here and a 1 here. I had a 50-50 chance of guessing right. Let's check real quick to see if we can multiply this out and get right back to this line right here. I'll erase what I do here, guys, so maybe off to the side in your notes. First product, 5n times n, that's a 5n squared. Outer product, 5n times a minus 1 is a minus 5n. Inner product is a negative 2n, and then the last product, negative 2 times negative 1, is a plus 2. And if you look at those two terms in the middle, they combine to a negative 7n which is not what I needed to see right here. So that tells me I guessed wrong. So instead of 2 and then 1, it would be significant here if we flip that around to make it a 1 and then a 2. And let's check that one. I think we're in better shape now. 5n times n is a 5n squared. Your outer product is a minus 10n. Inner product is a minus 1n. Okay, now we're in business. And a minus 1 times a minus 2 is a plus 2. Those terms combine to a negative 11n. That is what we needed right here. So check. We've got that one right. Okay, so we factored it. Now we take each factor, a and b, and set each one of them equal to 0 and solve. So 5n minus 1 equals 0, or n minus 2 equals 0. Either one of those will give us a solution. Here, on the left, you're going to add 1 on both sides and get 5n equals 1, and then we're going to divide by 5, and the answer's staring you right in the face. N is equal to, a non-integer answer of 1/5. This one's a little bit easier. All we have to do here is add 2 on both sides, and we get n equals 2. And it's always going to be the word or in between there, guys, and then we box this up. So here's another quadratic equation that has 2 solutions, but one of these is a non-integer. N is equal to 1/5, or n is equal to 2. All right, so those 3 problems, everybody, are kind of how we do solving by factoring. Now, your book decided to take just a minute here, guys, and I think I can do this with you here on my iPad, to talk about how to solve quadratic equations by another method, which is graphing. So, since you guys all have a graphing calculator, this will work for you here. We've got 3x squared minus 5x minus 4 is equal to 0. Now, this is going to look a little bit different for me on Desmos on my iPad than it's going to look for you on your TI-84, but I think you guys will get it. You guys are going to hit your y equals key up in the upper left-hand corner, and on that first line, y1 equals, you guys are going to type in this quadratic expression right over here. 3x squared minus 5x minus 4. Then when you're done with that, you're going to hit enter, and then you're going to hit your F5 button, which is going to graph this thing for you. So let me try to do this on Desmos. As I said, it won't look exactly the same, but okay. So I am graphing y is equal to, I should have written this down. Okay, oops, I hit a button already. Y is equal to, I believe we had just a regular x squared, and you'll notice this starts to graph as I'm doing this, which is kind of cool and kind of a pain. Oop, I forgot. 3x squared minus 5x minus 4. So let me go back and put a 3 right there. 3x squared minus 5x and a minus 4. And I'll just hit enter at the end of that. Okay, so this is what we're looking at here, guys. That should be about the same graph that you see on your calculator, and I believe you should see everything there. Now, what we're interested in now, though, is we want to know when this particular quadratic function has a value equal to 0. Okay, so when we talk about on this spot right here in a graph, where is the function equal to 0? The line y equals 0 is also known, everybody, as the x-axis. We are interested in the points where this graph right here is going to cross the x-axis. And as I think you can see, this upward opening parabola crosses the x-axis twice. One of them, I'm making a mess here. One of them occurs at this point right here in the middle of my graph, guys. So it's somewhere in the neighborhood of negative 0.6, but not quite. And then the next one occurs over here on the right about there maybe. Oh, somewhere between 2.2 and 2.3. So, all right, how do I get this back to the way it was supposed to look? All right, sorry everybody. All right, so your graph was probably looking something like this. And I think I went way too small on that. Okay, Mr. Fontana, you have messed it up. Do I remember how to do this on Desmos? It should be a standard thing right here, but now I can't find it. Okay. All right, so can I change this around? Oh, I've messed this up. All right, all right, all right. Anyway, this is going to look different on Desmos than it is for you guys on your 84 anyway, but if we kind of plot this right here, you guys are going to use a feature I'll show you in class how to do this called the trace feature. But when you get to right about there, I was hoping it would jump out at you here, guys, with a y coordinate equal to 0. There it is. So my first solution here, that x value, is negative 0.591. I will show you guys how to get that from your calculator, but I'll just write this down. X equals negative 0.591. That's one solution. Or, now let's find that second solution. All right, so if I bring this guy over, here we go. Looks like our second solution should be right about there. All right, my calculator tells me that it's 2.257. You guys are going to have to work a little bit harder than that to get it, but all right, x equals 2.257. You'll notice this calculator rounded those answers to 3 decimal places. It probably actually goes on a lot further than that, but that's it rounded right there. And I'll be specific with you guys as to what accuracy level I want you to put for your answer. Okay, so that's what that looks like. You guys will use a feature on your calculator called the zero feature, and I'll make a second video showing you guys how to do that and post that here pretty soon. Let me show you how to do one that looks like this. If it's not already equal to 0, that's fine. We can do this the same way, but that left side of the equation, we can graph that as y1, and then the right side of the equation, we can look at that as y2, and we can graph both of those at the same time on the TI-84 and find out where they cross. So I tell you what, I don't think I'm going to bother showing you how to do that here in this video, but I'll make that second one using the 84 and show you what that's going to look like for you guys. Okay then, everybody, that's all I've got for you then for section 4.5, so let's give that homework a try. Good luck.